Hello and welcome to this tutorial on pixel mapping and its applications. At its most basic, pixel mapping is a method of overlaying media such as images and video onto a grid of lighting fixtures, which could be anything from parkans to a complex LED screen. The desk interprets this into colours and intensities for each pixel and sends the information via DMX to the rig. I'm assuming a basic knowledge of DMX controlled lighting here. There is plenty of information available elsewhere on these subjects for those that need it. At its most basic, pixel mapping can be used to quickly create dynamic chases. In this example, I've set up a 4-lamp bar of generic PAR56s and then patched these to sequential addresses on my control surface. To enable pixel mapping to work as intended, the fixtures must first be laid out in order on a grid, with each luminaire forming one pixel. This ensures that the desk is able to send the correct part of the image to the correct pixel. With this grid in place, it is then possible to overlay an image. I will now create a basic 4-step chase using pixel mapping. First, I open up the first layer and create a shape, and then position it over the first fixture in the sequence. I then add an animation that causes the shape to travel across all 4 fixtures. Every parameter of the animation can be adjusted in real time. For instance, by doubling the spawn rate, we now have a 1 in 2 chase. It's also possible to reverse the direction of the chase by changing the movement direction of the animation. While this is useful, where pixel mapping really comes into its own is with fixtures capable of colour mixing. Here is a bar of 4 LED PAR56s patched and laid out exactly like the generics in the previous example. By using the same steps as before, we are able to create a 4-step chase, but now by changing the layer colour, we can set the chase to any colour we desire. Another very useful feature is the ability to create multiple layers. By creating a second layer, setting the opacity relatively low, and enlarging the shape to cover the whole array, we can create a coloured background to our chase. While these are relatively small-scale examples, it's easy to see that pixel mapping can greatly speed up the programming procedure and provide an intuitive and dynamic way to control chases. For this final example, I will create a low-resolution LED screen to demonstrate the full potential of pixel mapping on a large scale. After patching the RGB pixels, we are able to array them into a grid of our chosen dimensions. This function makes the arduous process of dragging and dropping each individual pixel much quicker. With this array assembled, we are able to apply large-scale, multi-layered animations that can create impressive visual effects with unparalleled ease. Thank you for taking the time to watch this tutorial. I hope it's been informative. For the purposes of this video, I've been using an Avalights Titan Mobile control surface. For more information on this particular system, Avalights have a range of training videos available. However, there are also many other alternative products to choose from.